And it just keeps going, right? Okay, so now what we're going to do is, all right, take a look at three different topics all together, right? So parallel, perpendicular, and congruent segments all in the coordinate plane. All right, and we've talked about all of these concepts already this year. So once again, right, trying to take what you already know, some baseline knowledge, right, and then put it all together, all right, in the coordinate plane. So now just to get you thinking a little bit, we have our opener here. All right, so which segments in the figure to the right are congruent, and how do you know? All right, and if two segments are congruent, what does this tell us about their measure? So what I'd like you to do is go ahead and pause the video, all right, do this opener, flip it back on, and then we'll talk about how that connects to the coordinate plane. All right, so hopefully you remembered that when we see the same types of markings, all right, that means that things are congruent. So for example, I can see that segment ED and segment DC both have 3 tick marks. So that means that those two segments are congruent. So ED is congruent to DC, all right? And then we can also see that BN and MF here, all right? So MF and BN both share the same type of markings as well. So those two segments are congruent. And we can see that angles are congruent, right? These two angles are congruent and these two angles are congruent because they have the same markings, right? Okay, and that really is, how do we know, right? Same markings, right? Right, so if they are marked the same way, that implies they are congruent. Now, if they are congruent, what does this tell us about our measures? Right, so that means they would have the same measure. So even though we don't know the length of these two segments, we may assume that they would be the same. Okay, so we know their lengths or their measures, all right, would be equal. All right, so we know they're going to be equal, whatever that measure is. So if we knew this was 13, this would be 13 units. If we knew this was 4, we knew this would be 4. All right, and that's the difference. So when we're working in this, we're typically, all right, not talking about specific measures. All right, we're just thinking about like interchangeable parts, right? So I could take one thing out, I know the next thing would, I could put it right back in, it would be the same. Okay, all right, now, okay, how does this, all right, transition to the coordinate plane, right? So now let's say we had these two segments in the coordinate plane here. We have A, B, and C, D. All right, so how do we know if those two segments are congruent? Right now, they don't have the markings like we did in our kind of geometric, all right, diagram up here. All right, and my guess is you probably are already thinking about how this connects to what we just did in our prior lesson, right? Well, if we want to know they're congruent, we need to know they have the same measure. Well, how do we find the measure in the coordinate plane? That's right. All right, Pythagorean theorem. All right, so we would just jump in and do the Pythagorean theorem here. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Right, create that right triangle. All right, 1, 2, 3, 4. 1, 2, 3, 4, 5. Right, create that right triangle. Now, you probably can tell once we draw the triangles that yes, this distance and this distance have to be the same, right? They both have the same legs there, right? Okay, but just so we can see that, right? So 4 squared plus 5 squared equals d squared. All right, so 16 plus 25 is equal to d squared. All right, and then that means 41 would equal to d squared, right? And so now when I take the square root of both sides, I get the square root of 41 is equal to d. And you could leave it like that right now, because remember, we're just comparing. We just need to know if they're the same. And so it doesn't matter if we leave it in this kind of exact form or if you get your decimal, right? And notice if we did the same thing for our second one here, all right, we get 4 squared plus 5 squared also equals to d squared. And from this point, you're probably like, yeah, they look pretty good, right? But we want you to do the math just to be sure. And we are also, once again, practicing this skill, right? Can I find the distance, right? Take the square root of both sides, and the square root of 41 is equal to d. So you can see, right, that those two numbers are the same. They have the same measure. All right, so now we're really working in reverse. Here, we knew they were congruent, so therefore we said they have the same measure. All right, what we're going to do in the coordinate plane is go in reverse. If we can show that they have the same measure, then we know that they are congruent. So same measure. So what that tells me now is that AB is going to be congruent to CD. All right, and so that's how it's going to connect to what we just talked about in our previous lesson. So let's flip the page here, right? All right, so congruent segments, right, are segments that have the same measure. all right, or length, if you will. Okay, all right, okay. And we saw what we just did here, right? So you might have a segment, right? Okay, so that we know that's congruent, right? We know this notation, all right? So, okay, same measure, right? And then maybe we have numbers, right? So this is 3, this is 3, right? Okay, all right. So the length of a segment, we've kind of already talked about this, right? But this is basically the distance from one end point to the other end point of the segment. All right, and these diagrams really show that up here too, right? No, that is a very bad arrow. Let's try that again. Fill it in there. There we go. All right. Okay, haven't had enough coffee this morning. All right, so that's that. And then we've already talked about the Pythagorean theorem, right? So a squared plus b squared equals c squared, right? We want to just create that right triangle whenever we can, right? A, B, and C. Okay. There you go. All right. So just once again, a lot of review. All right. So hopefully some of this is really starting to feel almost second nature to you. All right. With the process that you need to do. So just to summarize that, right? Okay. So determining if segments are congruent, right? So we want to use the Pythagorean theorem to find the length of the first segment. All right. We want to use the Pythagorean theorem to find the length of the second segment. Typo there. All right, did not catch that when I proved it the first time, but caught it this time. All right, to find the length of the second segment, right? And then we want to compare the two lengths, right? If they are equal, then the segments are congruent. If the lengths are not equal, then they are not congruent. So pretty straightforward there, right? And then if they are congruent, we want to go ahead and write our congruency statement, all right, like we've done in the past. Now, so we're going to find out if segments are congruent. We're also going to talk about, all right, are those segments parallel or perpendicular? Because this is going to lead into, all right, the next lesson, right? And we're going to go back to classifying, right? Like, how do I know if this is a parallelogram, right? How do I know if this is an isosceles triangle? And so to do some of those things, we need to know if lines are parallel. We need to know if those line segments are perpendicular. So, all right, I would like you to pause the video and write down, how do you know if two things are parallel, two lines are parallel in the coordinate plane, and how do you know if they are perpendicular in the coordinate plane? Flip the video back on and we'll go from there. All right, so hopefully you said that the slopes are equal and they have different y-intercepts, right? So we want to make sure we have, all right, so slopes are equal and they have different y-intercepts because we want to make sure we're talking about two different lines, right? That's really what this part is signifying, right? Now we're talking about two distinct lines. All right, how about perpendicular? All right, slopes are opposite and reciprocal. There we go. See if I can spell that. All right. So opposite and reciprocal. Now, for some of you, when we had this test a couple of units ago, right, that was one of the things that caught some of you, right, is that both of these things have to be true for things to be, or for two lines or line segments to be perpendicular. So make sure that you know opposite and reciprocal. Opposite and reciprocal. All right, so let's go back, or let's flip the page here, and let's look at number 1 here. Now, we've already found the distance here, right? So I drew this in a second ago. So 1, 2, 3, 4, and then over to 5 here. And then I drew this in. This is 4, and then I drew this in, and that was 5. So I'm just going to refresh that, right? Okay, and we know from the work that I did, okay, with you over here that we already knew that they are congruent. All right, so I'm going to skip that part and go right to, all right, so we know that AB is congruent to CD, right? Okay, we saw that in the problem before. Now, notice, then determine if the segments are parallel, perpendicular, or neither. So now what I need to do now is find the slope of both segments. And notice this really helps me because once I draw my triangle, I really have my rise and my run, all right, to look at. Because notice my rise here is 4, my run is 4, so the slope of segment AB is 4 over 5. And then I can come down here. Here's my rise, here's my run here, and so the slope of CD is also 4 over 5. All right, so notice, all right, definitely two different lines, right? They definitely have two different y-intercepts. If we were to extend CB or CBCD there, we could see that. All right, they have the same slope. So what we know is AB is parallel to CD, just like that. All right, so drawing in those right triangles to find the length of the segment will also help you with the slopes. And it's just like that. All right, so let's go through one more together here. So let's look at number 3. All right, and right now, all right, we definitely know they're not parallel, right? They intersect. So parallel is off the board. All right, so we want to find the length, see if they're congruent. All right, and then what we want to do then is look at the slopes and determine if they are perpendicular or not. Okay, so I'm going to draw in my right triangles here. I'm going to start with this one. Let's draw in this guy right here. All right, so 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5, 6 there. All right, so when I look at CD, I get that guy. So when we look at CD, I'm just going to label CD right here so I know which one I'm talking about. All right, so it's 5 squared plus 6 squared equals D squared. All right, and that would be 25 plus 36 is equal to D squared. And that would be 61 is equal to D squared. I'm going to take the square root of both sides. This is the square root of 61. And I'm going to leave it like that. If you want to do a decimal, that's totally fine. Remember, because we're just comparing, right? We just know if those numbers are equal. But if you wanted to do a decimal, you would get 7.8, right? So 7.8 is equal to D. All right? Okay, so now that's CD. So now let's look at AB here. So let's draw this right triangle in right here. I probably should have put in my right angle bar here, or box there. 1, 2, 3, 4, 5. 1, 2, 3. All right, and it definitely looks like when I look at AB here, so 5 squared plus 3 squared equals D squared, right? And then 25 plus 9 is equal to D squared. So this is 34 is equal to D squared. Take the square root of both sides. The square root of 34 is equal to D. Okay, and we can definitely see here, right, that these are definitely not equal, right? Okay, so definitely not equal. So we know that CD and AB are definitely not congruent. Okay, now let's look at the slopes here. So when I look at the slope of AB, all right, I go up 5 to the right 3. So my slope here is 5 over 3. When I look at the slope of CD, now I notice I have to go down here. All right, so that would be a -5, and I go to the right 6. Okay, so notice they are opposites, but they are not reciprocals. All right, so remember, to be perpendicular, you have to be opposite and reciprocal. All right, opposite and reciprocal. All right, so now notice, so we know they're not parallel, right? They intersect, and now we know they're not perpendicular. So, all right, so AB and CD are neither, all right, parallel or perpendicular. And there's some symbols for parallel and perpendicular if you don't want to write out the words, or you're bad at spelling like me. All right, so there you go. So there's our introduction to, all right, congruent segments, parallel and perpendicular segments in the coordinate plane. We'll do a little bit more work in class next time. I'll see you then.